Today we're going to talk about Sig Figs. What happens with Sig Figs is in science class, things are based off of measurements. And when we have numbers that are based off of measurements, we need to show how accurately somebody actually measured something. So what we have is a digit of uncertainty, and then we have the numbers that we can actually pull off of like a graduated cylinder or a balance or something else. So because everything that we do in science is based off of measurements, we have to use these Sig Figs to eventually round our answers for our math to show that accuracy that we used. So what we're going to do today is first we're going to look at some rules on is a number significant or not when we look at each individual digit, just to get a total on this is how many Sig Figs are in the number. From there, we'll actually take that knowledge and we'll apply it to some math problems to figure out how do we round our answers when we're doing math and chemistry. So the first rule is count numbers 1 through 9. So when we're counting numbers 1 through 9, what we're actually doing is we're looking at each individual little digit. And when we look at each individual digit, so example this one, we have a 6, a 3, and a 1. If you have a number that's 1 through 9 for that digit, it counts. So we count the 6, we count the 3, we count the 1. 631 has 3 Sig Figs to it. With the 0.14, the decimal doesn't matter in this case. For the decimal here, all that it shows is that it's a tiny number, but we want to look at each individual digit. So we count the 1, we count the 4. 0.14 contains 2 Sig Figs. Now the next 3 rules all have to do with zeros. Sometimes zeros count and sometimes they don't. So this first rule says count sandwich zeros. Now sandwich zeros are zeros that are stuck in between a number that's 1 through 9. Maybe you have more than one sandwich zero there and that's okay. Maybe you have 3 and then a whole bunch of zeros and then a 2 at the end. All of those are considered to be sandwich zeros. So with your numbers 1 through 9, again we're going to count the 5, we count the 6. Now this 0 that's there, that one is sandwiched in between the 5 and the 6, so we're going to count that one. This number has 3 Sig Figs. Now 20.01, that decimal place is there, but even though we have a decimal place, that doesn't matter. We still have these 2 zeros smashed in between the 2 and the 1, so we're going to count the 2, we count the 1. These 2 zeros count because they're sandwich zeros, so that one has 4 Sig Figs. Now this last number that I wrote down, we've got 1, 2, 3, 4, 5 zeros sandwiched in between the 3 and the 2. That doesn't matter, they still count. So that means that we have 7 Sig Figs on that number. Even if we had a decimal place like here, it still has 7 Sig Figs. Now the next 2 zeros are the zeros at the beginning of a number and the zeros at the end of a number. If we have the 0 at the beginning of the number, they never count. All they are is spaceholder zeros to show how small those numbers actually are. So what we're going to do is we take these zeros and we just skip over them. And the first zero that we count is this one, or the first number that we count is this 3 right here. That number has 1 Sig Fig. So these zeros just show how teeny tiny that number actually is. Same thing with this one, that 0 at the beginning of a number doesn't count. So because that number doesn't count, that one just has 1 Sig Fig. Now with this number, all of these zeros are all at the beginning of the number. Zeros at the beginning of a number never count. So we count the 4, the 3, the 9 to give us 3 Sig Figs. The last rule, these zeros, sometimes they count and sometimes they don't. So it's zeros at the end of the number. When we talk about zeros at the end of the number, just like up here, the zeros at the beginning of the number is everything until your first 1 through 9 number. Zeros at the end of the number is everything after the last 1 through 9 number. Zeros at the end of a number count only if there's a decimal present. So this 0 is at the end of the number, it's at the end of the 9. It is going to count because there's a decimal place in that number. So there's 2 Sig Figs in 9.0. The reason why that 0 is going to count is because somebody actually took the time to measure very accurately that it's exactly 9 centimeters or whatever else. Now the next problem, we have 900. With the 900, there's no decimal place written. Yes, it's implied that there's one there, but this means that that's pretty much an estimate that somebody just said, oh, that's about 900. So those zeros are just placeholder zeros. With your placeholder zeros there, all they are is showing how large the number is, so they don't count. With my 900 without a decimal place written, there's one sig fig there, and that's just the 9. Now, if somebody measured very accurately and it was 900.00, that actually has 5 sig figs to it, because all of these zeros count at the end of the number because there's a decimal place present. So this one only had 1 because there's no decimal place. This one has 5 because we have a decimal place in our number. So we're going to apply those rules, and I've got some practice problems to do. With my practice problems, we'll just kind of cruise through them, and I'll explain the rules again. But if I have 0.02, zeros at the beginning of a number never count for sig figs. So all I'm going to do is count my number 2, so that one has 1 sig fig. Now with this next one, zeros at the beginning of a number never count. I count my 2. This 0 at the end of the number counts because I have a decimal place present. So I count the 2, I count the 0, 2 sig figs. Now in 501, I count the 5, I count the 1. This 0 is a sandwich 0. Sandwich zeros are smashed in between non-zero numbers. So we count that 0 because sandwiches always count. We've got 3 sig figs. Now underneath that we've got the same number, but it's 0.0. So we already know that we count the 5, the 0, the 1. The 0 at the end of the number counts because we have a decimal place present. That one has 4 sig figs. Now this next one, we have 5,000. There's no decimal place written. So because we don't have a decimal place written, all that I do is count that 5. Zeros at the end of a number don't count if there's no decimal place. So there's just 1 sig fig there. My next rule, or my next problem, I have 5,000.0. So with my 5,000.0, all of these zeros are all at the end of the number. Those zeros all count because I have a decimal place present, so I have 5 sig figs. On this one, there's a sandwich 0. My 6, my 5, my 1 count. These 2 zeros at the end of the number count because I have a decimal place present, so we have 6 sig figs. On this next number, all of these zeros at the beginning of the number, they don't count until we get to the 5. The 5 is the only sig fig in that number. Zeros at the beginning of a number never count. Zeros at the end of a number count when we have a decimal place present. So I'm going to count this one. That's a sandwich 0, so I'm going to count that one, and I count my 1, my 2, and my 5. So we've got 1, 2, 3, 4, 5 sig figs in that problem. Now this last one down here, we have 10,001. I count my 1, I count my 1. These are all sandwich zeros, so that means that I have 5 sig figs in that problem. Now scientific notation you're going to run into occasionally. With your scientific notation, when you're trying to figure out your number of sig figs, you basically ignore the times 10 to the 9th in this case, or the times 10 to the negative 3rd. What you're going to do is you look at the number before the x for the times, and that's how many sig figs it has. Now it still follows all the sig fig rules. I count my 6, I count my 5 to give me my 2 sig figs. If I had like 6.50 times 10 to the 9th, then it would have 3 sig figs, or 6.500, 4 sig figs. Now in this problem, I count my 7, my 1, my 2, my 4. I ignore the times 10 to the 3rd. Sorry, negative 3rd. So I've got 4 sig figs in that problem. Now the reason why we need to figure out how many sig figs are in each of these different numbers is because we're going to do some math problems. And when we do math problems in chemistry, or physics for that matter, we're going to either add and subtract, or we're going to multiply and divide. You have different rules depending on which type of math problem you're doing. So the first one that we're going to look at is your addition and subtraction, and then we're going to look at multiplication and division. So what you do first is you take your calculator and you plug in all of your numbers to your calculator first. Then you get an answer. Once you have your answer, you round differently depending on which type of math problem you're doing. Now, if you're doing addition and subtraction, what you're going to do is you're going to look at your input numbers that you put into your calculator. When you put those numbers into your calculator, you're going to round your answer when you add and subtract by using your least number of decimal places. Or if you're doing multiplication and division, you're going to look at your input numbers and figure out how many sig figs are in each of the numbers. When you figure out how many sig figs are in each of the numbers, you round to the least number of sig figs. So addition and subtraction is decimal places, multiplication and division is sig figs. So let's put that into play here. Again, I've got some sample problems that we're going to do. I'm going to get my calculator. Now in this first problem, we're multiplying. So I'm first going to plug it into my calculator. So 1.35 times 2.467, we hit equals. Now once I have my answer in my calculator, I need to look at my input numbers, and I'm going to round this answer to reflect the least amount of sig figs as my input. So this number has 3 sig figs, this one has 4. So that means that my answer can only have 3 sig figs. So when I round this to have 3 sig figs, we read from left to right. So I'm going to pull the first 3 digits. I'm going to have 3.33 for an answer. Now if that 0 right there was a 9, then it would round to 3.34. So it's still the normal rounding rules that you learn in elementary school. Now the next problem, we have 1035 divided by 42. Now when you divide, you're going to look at your input numbers to round the answer to the least amount of sig figs again. So in my 1035, I have 4 sig figs. 42 has 2 sig figs. That means that my answer here can only have 2 sig figs. So I've got a 6 next door to the 4. That's going to round up to 25. Now in the next problem, I'm adding. When I add and subtract, I'm going to plug in all of my numbers to my calculator again. When I get my answer, I'm going to look at my input numbers. That has 2 decimal places, 1 decimal place, and 0 decimal places. So that means that my answer cannot have any decimal places in it. So I'm going to round this to a whole number. So I have the 53 point, the 2 makes the 3 stay the same. So your answer is just 53. Now on the next one, we're subtracting. So again, we're going to look at the least amount of decimal places for my answer. 55.46 minus 28.9, it equals. My calculator says that it's 26.56. Look at my input numbers. Here I have 1 decimal place. There I have 2. My answer can only have 1 decimal place. So we're going to round this so it's 26.6, makes the 5 go up to a 6. Now on the next one, we're dividing. 150 divided by 6. When we divide, I get an answer of 25. Now dividing, we're going to look at the least amount of sig figs. So here I have 2, here I have 1. That means that my answer can only have 1 sig fig. So my 25 can only have that place. That means that I have an answer of 30. 30 has just 1 sig fig the way that it's written right now because there's no decimal place at the end. On my next problem, I'm adding again. So I have 6.3 plus 12.58 plus 21. This has 1 decimal place, 2 decimal places, 0 decimal places. That means that my answer has to be a whole number. My calculator says 39.88. So I'm going to round that to be a whole number. So I need the 3 9. The 8 makes the 9 go up. So you get 40. Now when you're adding and subtracting, make sure you drop in a decimal at the end, because if we plug this number in later and we need those sig figs, we want to make sure that that's locked in to have 2 sig figs instead of just 1. Now here we have 505 minus 450.25. We hit enter. So we have 55.75. With that number, we have a whole number. We've got 2 decimal places. That means that my answer has to have a whole number. So I need those 2 digits. The 7 makes the 5 go up to 56. So with your Sig Figs, once you figure out how many Sig Figs are there, we have the different math rounding rules. If you can remember that addition and subtraction, you're going to round your answer to the least amount of decimal places. Or if you're doing multiplication and division, you're going to round your answer using the least amount of Sig Figs. That's going to be the greatest help to you as we go through the math for the rest of the year.